Hello and welcome to another video with Mate Evans for rapid radar plotting. Today we are going to be doing a 2-target plot. It is plot number 14 in our rapid radar plotting packet. If you're following along with that, page 47. For multiple target plots, you want to focus on each target individually up until the point where you determine a course or speed change. Yes, you're doing multiple targets at the same exact time, but they're not dependent on each other, so it's easier to just focus on each one separately. You will end up with several plots all on the same page. When it does come down to figuring out your new course or speed, you want to focus on what target is the most dangerous target, and we'll get into that shortly. Let's start up with setting up all of our plotting equipment, 2 triangles, and some dividers. As you can see, my dividers are both points of equal length with pretty sharp lead on one side of it. Today I will be using a pen just so I could show all of the different colors and relative motion lines, etc. to all of you guys, but I do strongly recommend a very sharp pencil. So let's start with our own ship's info. We have a course of 042 degrees true and a speed of 11.2 knots. Our minimum CPA to maintain is 1.5 nautical miles, and our maneuvering point, or MX, is 1209. So, at 12 o'clock, we take our first range and bearing of target number 1. At 12 o'clock, target 1 is bearing 045.1 degrees true at a range of 5.4 nautical miles. Today, we will be using a 12 nautical mile range scale to help you get set up with your actual ranges and bearings. So we make our little bearing mark. We take our dividers, measure out that 5.4 nautical miles. And once we get that measurement, we make our little hash mark on that bearing line. We always want to make a crosshairs on our paper. If we do a bullet point or just a filled in circle, we're not going to get the accuracy that we need. So make sure to just always have that crosshairs. Again, I strongly recommend in all my classes, get a divider with sharp lead. We label that first range and bearing R, 12 o'clock, and we make sure to label a number 1 on it as well to show that this is one target. Later on, this will be important to distinct throughout all of the different targets we have on our piece of paper. So at that same time of 12 o'clock, we also take a range and bearing of target 2. This bearing is 347.3 degrees true at a range of 6.1 nautical miles. We can write that in a separate corner, again labeling our little bubbles in those corners 1 and 2 so we don't get our information confused. And for the rest of this video, I'll fast forward all of these ranges and bearings, making sure you have the info, but feel free to kind of pause and work ahead. Target number 1's second range and bearing is 1206 with a bearing of 045 degrees true and a range of 3.5 nautical miles. We label it M with the timestamp. Target number 2 at 1206 is bearing 346 degrees true at a range of 5.1 nautical miles. Now I want you guys to connect all of your relative motion lines, create your ease using our speed with a 6-minute differential, and solve for everything. I'm going to speed this video up even more so that you can find all the values yourself and see if they match mine. Please use this time to pause the video now before I reveal all the answers of relative motion, true motion, CPA, TCPA, and what situation we have. Okay, so here's all of the information. Again, give this video a pause to check your numbers versus mine. Now we're going to move on to actually figuring out what target we are maneuvering for. First, we're going to draw in our minimum CPA range circle. Since it's 1.5, we don't have it on an exact range ring on our plotting sheet. So we simply just draw it in. My recommendation for drawing in a circle is to spin the paper instead of spinning your dividers. As you can see here, I can't get a perfect grip on a perfect circle, and that may change the actual distance it is from the center for you guys. So with that minimum CPA of 1.5, both targets are going to go into our CPA. So we ask ourselves these two questions in this specific order. Who will we hit first? Or, AKA who has the fastest TCPA. If they both are the same, then we go to the second question, who is the furthest right? Well, we could see for both of these questions, target number 1, about head on with us, is going to hit us first. So let's figure out where their MX is going to be and then solve for the new course or speed change. One quick way I like to do no math at all, if I'm on a 6-minute scale from my R to my M and my MX is 3 minutes later, I can take that distance measurement of R to M, which comes out to 1.9, and basically just half it to show 3 minutes in the future. Now I can do this same method with my other target as well. This is a great way to be able to solve for your new course or speed change right away before calculating all of their relative speed, true speed, etc. It's just a little quick, no math way to find your MX sooner. So I have both my MXs for both targets. I know I'm solving for target number 1 for my course and speed change, so I'll work off of that MX point, maneuvering point, to go just outside of my minimum CPA of 1.5 nautical miles. Whenever we are lining up our MX with our minimum CPA, you want to be right on that outer edge of your minimum CPA. We draw that line out. We label it new RML with a number 1 circled to show that it's for target number 1. And then we do the same thing as usual. We bring that new relative motion line from MX backwards through M. They're 1206. I want to make sure that's lined up really well before we shift it over. As you may have noticed from doing other plots, any small shifts will make a big change in your answer, and you might fall just outside of those Coast Guard tolerances. So we shift our triangle up, keeping steady hands. Now with our dividers, we put our lead side on R and our non-lead side on E, and we swing out E to R along that new relative motion line to create our R prime. E to R prime represents our new course. Now, with this plot in particular, we cannot do a speed change at all. Not only is our new relative motion line worked backwards outside of the original ERM triangle, but also we are in a head-on collision with target 1. So even if we slowed down to 0, even if we went backwards, we would still be head-on. So now let's see what our E to R prime angle comes out as. Right now, this is a question mark on if we can actually do this new course change, because first we have to double check with all the other targets that it does agree. So let's steady up our triangles. I line up that line on my triangle from that E to R prime, and then slide my triangle over to see where that line hits. So looking at what I measure out, I measure a new course of 099.5 degrees. Again, this is a question mark. We're not 100% sure if this will work for every single target. That's why we're going to get into the new phase of why multiple targets is a little bit more work. So now comes the exciting part. Now we're going to make sure that our new course, our E to R prime, works with all of our other targets. So what we are going to do, we are going to shift our E to R prime to all of our other targets. E is a constant for every single other target on the page. So we take that new course of 099.5 degrees, our E to R prime, and we shift it to every other target starting from their E. Because again, we are E to R. So we just make that line. Now we basically create their new relative motion line backwards from how we did before. When we first created it on target number 1, we went from new relative motion line to mx, and then mx backwards from m. So we're doing the opposite. We're going from r prime to m, getting that angle, and then shifting that angle outward from mx as its new relative motion line with our course change of 099.5 degrees true. With this example, yes, r prime to m on target 2 is a little small, but we are still able to follow our methods. So we do that same angle, r prime to m on target 2. This is the new relative motion line of target 2 once we make that course change at 1209 to our new course of 099.5 degrees. Since their new relative motion line is outside of our minimum CPA, our new course change works for both of these targets. And we are completely done with this problem with our new course of 099.5 degrees true. Remember, you always want to make sure that you find out what the dangerous target is by asking the 2 questions in the following order. Who will we hit first, and who is the furthest right? If for some reason your new relative motion line of your secondary target does not go outside of your minimum CPA, then you solved for the wrong target and you have to start over. I hope this video was helpful for you guys. Feel free to leave comments or suggestions. Have a great rest of your day. Bye.